Do you have concerns with the safety, taste, smell, or discoloration of your well water? Then this video is for you. Today, we're joined by Mark Timmons, the president and co-founder of US Water Systems, and he brings over 50 years of water experience to drop some serious knowledge on well water systems from A to Z, including what water treatment solutions work best for common well water issues like iron, sulfur, rotten egg smell, bacteria, even tannins, and he'll cover solutions that actually work and what are all of the pieces, what things do you need, how do they fit together, things that you don't need. And then he'll cover common pitfalls and mistakes that a lot of people tend to make when putting together their well water system that you can avoid by listening to Mark in this interview. So stick around because it's all coming up. Welcome everybody back to the Freshness Info series. Today we are with Mark Timmons from US Water Systems, the president and co-founder. Thanks for jumping aboard today, Mark.
Thanks for having me. I appreciate it.
Today, the purpose of our video interview is to provide the ultimate well water guide, and Mark is the best person that I could possibly think of to have him on here. So I'm super grateful to have some time to go over folks that have well water from A to B to C to D, go through the whole process, cover the things you might need, what you might not need, and then most importantly, what the best treatment solutions are. So before we dive into it though, I'll just let you, Mark, give a little bit of background with your experience in the water industry, and we'll go from there.
Okay, well, I started out as a child. I actually turned down a scholarship at Ohio State University when I got out of high school and decided to become a plumber. So that shows you how smart I am. And I served a 4-year apprenticeship as a plumber, got my plumbing license, and then decided, I don't really like this that well. And that's when I got into water treatment. This is my 50th year actually in water treatment, and started as just a typical dealer, the Culligan dealer type thing. I mean, we went out and made house calls, tested people's water, put systems in, installed them, and I did that for, 30 years. Had a representative variety of different companies, served in a number of capacities. It's bought and sold a couple of dealerships, and just learned how to do everything the hard way. It always helped me that I was a good plumber, even though I didn't like it. And putting pipes together, you still have to do that with water treatment, and so that served me well. And then turned out I was the national sales manager for a large water treatment company out of Los Angeles. This was back in 2003, and I had to leave due to illness. They were sick of me, and so started my own company again, and it just started doing it the same way we always did it. I was US Water Systems, and my wife and I started in our garage. It was 20 years ago. And, I'm out in the field working, from 6 a.m. till midnight, and, doing what you have to do to start a company. And, but then I started thinking about this thing called the internet, and think, man, there might be something to this. So I'd come home at 9, 10 o'clock at night, and I'd work till, 2 or 3 in the morning building our website. And believe me, I am not a web developer by any means. And the software I used was horrible. I worked months on developing this website. And then, one day it went live at 10 o'clock in the morning, and we put $200 into Yahoo and pay-per-clicks. And at 11:21 in the morning, we got our first order from Morristown, New Jersey. And, the site was horrible. I would have never bought anything from it, but, we did $2,500 the first day. And so the rest is history.
Well, so 50 years in the water industry, I believe you are a master water treatment specialist, and which is a big deal. I personally don't know of anyone else that has that designation.
We have 3 other people at our company that are in the process of getting it done too, because we really push certification and training and things like that. So I won't be the only one, but I am officially the longest tenured one, just because I'm the oldest.
Right. So you've seen it all, and that's why we're lucky to have you here today. So let's start with how the water flows from the well through the home, but more importantly, then we'll kind of stop in the middle to focus on, what are the best treatment options for common well water issues. So if we start all the way at the beginning, it of course starts by the well, but then we come to the pressure tanks, and we won't spend too much time on this, but I just wanted to quickly add a little bit of color between the types of pressure tanks for those folks that have them, between the galvanized tanks and the newer, more modern bladder tanks. How do those 2 items impact people's options and how they might look at treatment solutions?
Let me go off the rails just a little bit and add back that when I first started in business back in 1976, somewhere around there, I contacted a well driller, and they had this newfangled new well drilling rig that was a rotary, and he was drilling 4 holes a day. And so I said, look, are you putting in pumps and pressure tanks and water treatment systems? He said, no, I don't have time. I said, well, all you do is just give me the names of the people that you're drilling, and I'll contact them a day later and see if they need a pump, pressure tank, or water treatment system. Well, I did that for about a year, and it was like shooting fish in a barrel, because these people needed pumps, pressure tanks, and water treatment systems, and he didn't offer that. And so, I put thousands over the years, I've put thousands of pumps, pressure tanks, and water treatment systems in people's homes. So that's also served me well, because I understand submersible pumps, pitless adapters, the pressure tanks. If you've got an old galvanized tank, which there aren't many left now, most of them are gone, but there's still a few of them out there. You need to get rid of that. That's the worst thing you can possibly have on well water, because simply what happens is, with a bladder tank, the air is separated from the water. There's a bladder on one side that has a preset amount of air in there. And by the way, the amount of air in the tank should be 2 pounds less than what your pressure switch is set to kick on at. So if you got a 30-50 pressure switch, if your pump kicks on at 30 PSI and off at 50 PSI, you should have 28 pounds of air in that tank. The reason is, you don't want to get every drop of that water out of that tank, because you would have an instant with no water. So you want to make sure, and that's a problem. Sometimes people just put too much air in the tanks. In fact, some people think if they put more air in the tank, they'll have better pressure. It's not true. And so what happens in a galvanized tank, the air is not separated from the water. And as a result, the oxygen in the air, which O2, oxygen is a good oxidizer, and it oxidizes some of the iron or sulfur that's in the air, that's in the tank. And what ends up happening is that oxidized, it turns it from ferrous iron to ferric iron, which is very difficult to remove. And you're creating problems that you don't need to create. I mean, I've seen 3/4 inch pipes that have a pencil thin, hole down the middle of them, because they're lined with iron or sulfur or manganese and things like this. So if you've got a old galvanized tank, get rid of it, get a bladder tank. They're all good. Amtrol's good. Flexcon. I mean, there's a number of tanks that are excellent on the market. A lot of different brands, but they're usually made by a couple of companies.
So after the pressure tank, we move into typically some sort of pre-filtration sediment filter that gets rid of that really heavy sediment that's common with well water. What are the pros and cons of each type of sediment filter, and how should people be looking at what type might be best for their circumstances?
Okay, here's where we get into something, and people think, well, a sediment filter is a sediment filter. Well, there's a lot of differences, and there's a lot of ways to make something cheaper. All our sediment filters that we have are made in the USA, 100%. all the cartridges that go in there are made in USA. One of the things that we do a little bit different with our sediment filters, and anybody could do this, but most of them don't, is they have what's called a double open end cartridge. There's a hole in the top of the cartridge and a hole in the bottom of the cartridge, and it aligns somewhat centered inside the housing. And then it kind of pushes into the top of that filter, and that makes the seal. Problem is, under really high flow, you get what's called wobble. The filter can wobble a little bit, and the water that's going through that cartridge can literally bypass some of the cartridge, and so you get some unfiltered water through there. What we did several years ago, we made our own housing that had a double O-ring. It has a filter that slides up in there, seals positively, so we get 100% filtration. And if you're talking about filtering, I mean, I see string filters, I see sediment depth filters, which are pleated polyester, and I see pleated filters. String filters, a lot of people say, well, I love string filters because I don't have to change them very often. Yeah, you don't have to change them very often because they don't work very well. They don't, I mean, take the filter out and you won't ever have to change it, you know? But if you put a cartridge in there to filter it, what you want to do is you want to filter as much of that sediment as you can. Sediment depth filters, which a lot of people use for the whole house, are not good for the whole house because you're relying on surface area and they just don't have much surface area. Whereas pleated polyester, not paper, but pleated polyester filters have a lot of surface area. For instance, they got 4.5 by 10 and 4.5 by 20 cartridge filters. Our 4.5 by 20 has 36 square feet of media. That's why it's pleated like an accordion all the way around. It has 36 square feet of media. Our nearest competitor has 24 square feet of media. We've had that exclusively made for us, so it filters better and lasts longer. Compared to a string filter, you can run, we did test years ago where we had 2,000 gallons of water that contained a lot of sediment, and we filtered the exact same thing with a string filter, with a sediment depth filter, and with a pleated polyester filter. And for whole house applications, the pleated polyester is unmatched because I don't remember the exact statistics, but it was something like we trapped like 6 pounds of sediment with the pleated polyester filter in 2,000 gallons. With the string filter, it was less than 1 pound of sediment. So, you know, most of it was getting by. And the sediment depth filter trapped about 2 pounds before it shut down, and you didn't get any more water out of it. So that's one thing that I can always tell people: if you're doing sediment filtration, sediment depth filters are always great. Now, depending on what kind of sediment you have, you may want to put what's called a spin down filter ahead of it. There's several companies that make these, Lakos and other ones. But you may want to put a spin down filter, and what they do, they have a housing that some of the sediment spins down and falls at the bottom, and you can blow it out. And sometimes that's necessary. A lot of times it's not. A lot of times it's overkill. But that's a very good way to start. Now, we also have backwashing sediment filters, but you should always have a sediment filter ahead of it. And I like, unless you just got really crazy amounts of sediment, I like to start with a 5 micron filter. Sometimes we have to do a 10 or a 20 if they've got really, really crazy amounts of sediment. And sometimes we have to do what's called step down filtration. That's where maybe you start with a 20, a 10, a 5, even go down to 1. And then there's another thing. It's called colloidal clay. You can't filter it out. It's not going to filter out. You'll see it in the water. You'll see it floating. It may settle after several days, but it's rare. But we see it maybe 5 or 6 times a year. You just can't get it out. And to get that out, you have to use ultrafiltration, which is pretty expensive, but it's the only way you're going to get out. So that's the pre-filtration.
After moving from the sediment filter, we kind of get into the meat of the water treatment and looking at more focused or specialized treatment options for very common well water issues. So of course, the first thing that you want to do before treating anything is run some testing. Maybe you can just cover what you would want to do for testing your well water, and then also the bacteria separate testing.
Okay, let me preface this with city water. If you want to test it, you can, but we can pretty much go to any city, any municipality, which is required by the EPA to publish their results. And if we know what city you live in, we can simply pull that municipal report up, and we can see what's in your water supply. So that's not difficult. But on well water, nobody publishes your results. And wells, you can say, well, my well's the same as my neighbor's wells. I've seen wells that were drilled 5 feet apart that were dramatically different. So, it just depends on where you're getting in the underground rock strata, where it ends up. I mean, there's just a lot of things that come into play with a well. So this falls under the category of measure twice, cut once. An old carpenter told me that, measure twice, cut once. And I'm not saying you need to test your water twice, but you need to have a good laboratory water analysis. And over the years, we've been with lots of different labs. None of them are perfect. But we deal with one lab for the most part, and we've got a good rapport with them, and they've earned our business. Occasionally, every lab has a problem, but for the most part, it does very well. Typically, what happens is people buy a laboratory water test from us. We send them a box that has the bottles in it and the directions on what to do. And then they take the bottles and they fill them with water. They put them back in the box. It's got the postage on it, and they send it to the lab. And it typically takes about a week to get the results back. Some people want to solve their problem. I mean, they say, well, just imagine I've got the worst water ever. What's it going to be? Oh, it's going to be $100,000. Because the worst water ever, it's totally subjective. Everybody we talk to thinks they have the worst water ever. And I talked to a guy yesterday who said, man, this is the worst water ever. And I looked at it and I said, well, I know it's bad and you don't like it, but this is a piece of cake for us. This is a walk in the park for us. It's not a big deal. You're going to love your water. And then there's some that present huge challenges. So the only way you're going to know how your water treatment is going to work is if you know exactly what's in the water, what the pH of it is, what the alkalinity is. You need to know the mixtures of cations and anions, which are chloride, sulfates, carbonate, bisulfates, sodium, calcium, magnesium, potassium, and all these things. You need to know all those constituents, how much iron's in the water, how much manganese is in the water. And then we have tests. A lot of wells have iron reducing or sulfur reducing bacteria. This is literally bacteria that eats the iron or eats the sulfur, and then they die and leave their rotting dead carcasses. See what I did there? They leave behind a sludge, and it's a mess. It's hard to deal with, and it has to be handled properly. So if you put a system in that is designed not to handle iron bacteria or sulfur bacteria, you will hate it, and you will never be successful with that. So it's always good to measure twice, cut once. It adds a little extra cost to test for the iron or sulfur bacteria. A lot of times you can look in the toilet tanks and see if there's any slime in there. If there is, then you've got a pretty good idea that it's there. This is a test you have to do. There's a little vial that you put the water in, and you let it sit for 7 to 10 days. And if the bacteria is there, it forms. You put it on top of your refrigerator or someplace that's not extremely hot but not cold either, and let it ferment and let it process for up to 10 days. Once you know all that, then you know how to treat the water. I mean, you can apply a sound scientific method to treating it. There can be competing contaminants. So you may have contaminant A in the water, which would normally say, okay, we're going to use product this, ABC, to take it out. But wait a minute, we've got contaminant D in the water, and that's a competing contaminant. So therefore, the process that we were going to use to treat it isn't going to work. We know all this. And because we've been there, done that. And I always say what makes an expert is somebody that's made a lot of mistakes. And believe us, we're experts. I mean, over the years, we made a lot of mistakes. But once you know what's in that water, you can predict for a certainty that it's going to solve the problem. And one of the new things that we've just implemented this year was we're giving a 1-year money back guarantee, which nobody else does. I mean, I've seen 6 months, but I've never seen 1 year. Because if you apply it properly, it's going to work. Very simply, it's going to work. And, you know, over the years, about 30 years ago, I was one of the pioneers into hydrogen peroxide treatment for well water. For years and years, everybody used chlorine. Chlorine's a great disinfectant, but it's not nearly as good of an oxidizer as hydrogen peroxide. And so back when I first started, we took iron out of the water with water softeners. Now, I tell people, look, if you've got significant amounts of iron, and I'm talking like over 1 part per million, you need to get an iron filter, because water softeners are designed to soften the water. They work on ion exchange. And under certain circumstances, they will remove iron, but they don't generally do it for a long period of time. It's not sustainable. And so, you know, people put it in their house, oh, they love it the first month, and then gradually their water quality declines. Iron, sulfur, and manganese need to be oxidized.
So real quick though, before, sorry to interrupt you.
That's okay.
Let's make this is like a perfect transition, but I want to make sure that that we kind of outline when you go from testing, you get your test results back, you know exactly what's in your water. And I think that the measure twice, cut once analogy is absolutely perfect. And it's critical to understand, just like if you went to a doctor and you had an issues, they're going to give you different testing and analysis. It's no different here. And you want to make sure that you're getting the right treatment for your specific issues. And to your point, so you don't end up spending hundreds of dollars on the equipment, installation, if you need a professional installer to come and do it, etc. You want to make sure you get it right. And so perfect segue into, we have our test, we can understand exactly what our issue is now. And you are kind of looking at, especially for well water, and this is why you have a really interesting perspective, and I wanted to cover this, so I wanted to make sure that we didn't just kind of gloss over this, on the research that you've done on treating specifically well water as it relates to sulfur, iron, and manganese, and hydrogen peroxide. And so if you get your test back and you have a lot of these common symptoms or issues, and I'll let you just kind of take the ball and keep running with it like you were. But if it's sulfur, iron, or manganese, what the threshold is, if it says you have this amount of sulfur, iron, or manganese, or if it's, I think where you were going is, or if it is up here or here, where are the thresholds and what are the best treatment options then? Okay.
And you know, your analogy about the doctor is entirely correct. There's no doctor that is a good doctor that you're going to call him up and say, hey, I've got a stomach ache or I've got a headache, give me XYZ medication. I mean, they're going to want to do tests. They're going to want to find out what's going on, and then they'll prescribe something. Same way here. Some people call and say, well, I just need a water softener. I need this, or I need that. Well, who told you that? Well, my neighbor's got it. You know, I'm sorry, but you know, we've got to make sure that what we're prescribing is going to work. What happens quite frequently is water is a fluid thing, and I'm pun intended, but the problem is competing contaminants prevent me from saying, well, you can take out X amount of iron with a iron filter or a water softener, or not. Let me give you an example. I've seen cases where we couldn't take out 1 part per million of iron with a water softener. And I've seen cases where we've taken out 44 parts per million of iron with a water softener. But it was based upon competing contaminants and other levels of pH and alkalinity and things like that. So unlike a lot of appliances or, you know, stereos or whatever it is, we're taking the water and we're running it through a machine and treating it. But other outside influences, other competing contaminants, sometimes prevent us from doing it the way we'd like to. I mean, you know, if you go out and buy a high-end receiver and a sound system for your TV, you know how many watts it's going to put out. You know what you can do. You know the frequency, and all that. Whereas with water, it's a little bit different, and it's really difficult sometimes to know exactly what you're treating. For years and years in our industry, chlorine has been the go-to. And about 30 years ago, like I mentioned, we started looking at hydrogen peroxide. And, you know, I remember the very first house that we did with hydrogen peroxide, they had horrible amounts of sulfur, and we couldn't get rid of it with chlorine, just couldn't touch it. And I'll never forget the first day. I mean, the homeowner was livid with us. I mean, the homeowner wanted to fight me. And, you know, I mean, literally. And I remember the first day we put this system into a well pit, and I was standing down in the well pit, and our service manager was in the house at the kitchen sink. And the way the peroxide system works is it injects peroxide into the line on the way to the house. Back then, we were doing it at injecting the peroxide before the pressure tank, which a lot of people still haven't learned. That's a very silly way of doing it, because peroxide doesn't react like chlorine. Chlorine requires contact time, whereas peroxide doesn't require any contact time. It's a much better oxidizer than chlorine. And all you're doing is diluting it when you inject it before the pressure tank. So it just takes more peroxide to do the same thing. But anyways, he was standing in the house, and I said, okay, the peroxide just hit the line. And he's standing in the house, and about 90 seconds later, he goes, the smell's gone. And this was a house, you could smell it half mile away. And I'll never forget that first one. I mean, it was just amazing. Here's the problem with chlorine. There's several problems with chlorine, and why people continue to use it, I don't know. I mean, I guess because they've always used it. There are times when you do need it, and that is mainly in surface water where you have algae in the water, and you need to kill that algae, and the chlorine does a better job than hydrogen peroxide killing algae because it's a good disinfectant. It's just not as good of an oxidizer. And so disinfectant works on the algae. But we've really promoted it because chlorine, when it's injected into cold water, which most groundwater is between 50 and 55 degrees, when that chlorine at the injection point hits that water, it tends to crystallize. And that injection point pretty soon blocks up. So all of a sudden, if you're using it to take out iron or sulfur, you're going to start seeing iron stains again because you're not getting any chlorine in there. So you got to take that apart. You got to clean the injector, put it back. If you're using a diaphragm pump, it requires a lot of maintenance. I mean, you're going to become intimately acquainted with the diaphragm pump and the injector, or you're going to have to pay a service man to come out there all the time and clean it and repair it. A chlorine injection pump is the single most troublesome device in water treatment that I've ever seen. Peroxide system uses a peristaltic pump, which is a positive displacement pump. And it's not unusual. We've been doing this for 30 years. We use Stenner pumps, but there's other ones that you can use too. We like Stenner. We know Stenner. But it's not unusual for us to put a peroxide system in, and that pump worked for 10 years without doing anything, without touching it, and without cleaning the injection point. Now, it's not in every case. You may have to clean that injection point, but the odds are you're not going to have to do much with that pump because peroxide is very easy on those things. It's a great oxidizer, not a good disinfectant. So one of the things we've learned is do not inject it before the pressure tank. The way we do it now is we do what's called proportional injection. We have a meter, and right before we have a backwashing filter that has catalytic carbon in. You can't use regular carbon. It's got to be catalytic carbon. And right before that filter, we're injecting the peroxide. We want it to be at full strength. Don't put a mixing tank. Don't even use a mixer. They have these mixers that have fins inside of them. and those knock out some of the air bubbles. We want to inject that to the tank so that right at the tank, so that peroxide is at maximum strength so it can oxidize better. And it does a fabulous job. Also, people think, well, I've got hydrogen peroxide in my water. What is the components of peroxide? H2O2, hydrogen and oxygen. Those are also the components of water. So in the process of oxidation, we're reducing the amount of peroxide, and then as it passes through the carbon, it's gone. Unless you're seeing dramatic amounts of air bubbles in the water, there's no peroxide left. So unlike chlorine, which when it combines with organics in the water, it forms trihalomethanes, which are known carcinogens. Peroxide doesn't do that. So to me, peroxide is the only drawback to peroxide is you have an annual peroxide bill. It costs more than chlorine, maybe a couple $100 a year. Some people $400 a year. But I'm betting the people that are spending $400 to $500 a year, and there are people that are doing that, you couldn't pry that system out of their cold dead fingers because it's getting rid of their problem.
And I'll put your hydrogen peroxide system, I'll put a link in the description down here, because it's a really, like you were describing, it's a really innovative system and it's extremely effective. But is there, aside from the hydrogen peroxide injection systems, are there any other treatments that might be beneficial for iron or some of these common well water issues, or aside from chlorine, things that you should avoid, or any pitfalls that people listening should be aware of?
Well, something that's very popular is what's called AIOs. They're air injection iron filters. What they do is they take a water softener head, and where the brine line normally goes in it, they just put a little filter on there, a little strainer, and they make it an air injection system. So when it backwashes normally, and then it draws the head of air into that tank. Instead of drawing brine, it's just drawing air into that tank. So in the top of the tank, you've got a head of air, maybe a foot and a half tall, and that air contains oxygen. And if you have absolutely no iron bacteria or sulfur bacteria, it'll do a good job. I would keep it under 10 parts per million of iron and 5 parts per million of sulfur as a rule, and it could vary either way. But if you have a hint of organic bacteria in there, it's not going to work. But the only problem with these air injection systems is the air's in contact with the upper part of the valve. And so as the water comes in there, it hits that air and it starts oxidizing. And we see some of the nastiest iron just glubbed up in there. Typically, at least once a year, you have to disassemble the valve, soak it in hydrochloric acid or something like that to get all the iron out of there. So, one of the things I always say is, if you're going to do that, make sure you either know how to do it yourself or put a cot in your utility room where you have the system so that your serviceman can have a place to stay, because they're going to be there a lot.
I guess.
Now we've came up with a way, and it wasn't my idea, but somebody else's came up with a way of, instead of putting that valve on the top of the tank, you can mount it on the bottom of the tank or on the side of the tank so that it's never in contact with the air. And I mean, it costs more, but you don't have to clean it like that every year. And now we're coming out with one that doesn't have an injector. See, the iron can plug the injectors. As they pull the air in, the iron can plug the injectors. We've got one now that's simply going to have a check valve at the top of the tank. It's coming out here in the next month or so. And it's just going to draw the water down and replace it with the air. We can use ozone too, but most of the time it's going to be air. And that eliminates all the service problems that we have with the AIOs that are mounted on top of the tank. If you're, I'm not saying don't use it, because if you've got moderate iron and you're not using a lot of water, then that AIO is going to probably work for a while. You're going to have to clean out the injector, which is not hard to do. It's a couple of screws to take off, and you clean it out, soak it in vinegar or hydrochloric acid or something, put it back in. and maybe do that every 6 months to a year, and you'll be in pretty good shape. But, you know, proper application is what's important.
The last thing that as far as common well water issues that people face is when you have this kind of yellow and brown water staining, which more often than not, it could be a number of things, but there's stuff, the tannins, and you've done a bit of work on this as well. And so I quickly wanted to touch on this with what are some options, of course, after you get your water tested and you see that this is in fact the issue, because tannins are surprisingly difficult to get rid of, and you'd think that they wouldn't be that bad. But what would you suggest if it turns up that you have a tannin problem?
Okay, that's a whole nother ball game. But
yeah,
tannins are highly unpredictable because there's different types of tannins. You know, tannins come from decaying vegetation. Tannins are what give tea its color. To take them out, this is an area we've been working in heavily for the last 5 years, and we're probably successful 85 to 90% of the time with our first method. And our first method is using a cartridge filter with a filter that's called the disruptor or the interceptor filter. And this is a filter that is made so that it has a positive charge of 53 millivolts. It attracts things like silica, iron, lead, arsenic, and it literally traps it in there so that it can't get out. It also does a very good job with tannin. But we can't predict for a certainty that it's going to do it. So what we do is we have a pilot test. You can buy it for like $59, and you can test it and hook it up to a garden hose and see if it takes out the tannin. If you can get 15, 20 gallons out of this little cartridge, you're good to go. We take it back and it all ends up costing you $20. So these cartridges are amazing. They have a positive charge. It's called the disruptor or the interceptor. It's a specialized made media. It's NSF approved and everything. It also takes out bacteria, but I wouldn't rely on it as the primary method of removing bacteria. I just wouldn't. I'd use ultraviolet or something like that. But in about 85, 90% of the time, it takes out the tannin. Now, you need to have soft water, iron-free water at that point. So this is the last device in the train, so to speak. This is the caboose. Unless you're putting a UV, and then you can put the UV afterwards. But if it doesn't work, then your only choice is to use it looks like a water softener, but it's a tannin filter. It uses salt to regenerate. It actually uses the chloride side of the salt instead of the sodium side like a water softener does. And we have a special blend of resin. We've learned how certain parts of the country respond to certain types of resin. This is an anion resin, whereas other types of the country, they don't work quite as well. So we blend this, so it's got a blend of both. And we were extremely successful. I don't think we've ever not taken it out with that, but it's very expensive. It's probably $400 or $500 more than a water softener because the media is a lot more expensive. Some people have taken and put this anion resin in with a water softener resin. The problem is it gets all mixed up together, and for this media to last, the water needs to be soft. And there's no way when you put it in the tank, it's going to be soft if it mixes together. You're still going to have the problem. So we use 2 separate tanks and do it that way.
If you have well water, because bacteria is super common in well water, how do you know if you should be just any well water bacteria treatment in general, whether it's chemical injection systems or a UV system? How do you know if that is something that is appropriate for you?
Well, with chemical injection, you're probably going to inject chlorine. And again, it goes back to, why I wouldn't use chlorine. I mean, it's going to produce carcinogens. You're going to have the maintenance problems with the pump and the injection point. And I just wouldn't do that. But I'm on city water and I've got a UV. I mean, have you ever had a boil order if you live on city water? You know, I mean, I've got it covered. I've also got that disruptor filter on right before the UV on city water. Don't really need it. It's a little bit overkill. But if I was on well water, I would absolutely have an ultraviolet disinfection system, because you just never know what can be in the water. And the peace of mind that you get with that is incredible. And, you know, I mean, it's a neighbor can drill a well or put a septic tank in down the road, and all of a sudden you're getting contamination that you didn't have last week, and you're getting sick, and it takes you months or years of figuring out what's happened. Just treat it. I mean, you know, city water, the municipality treats it with chlorine because chlorine is a good disinfectant. It's important to disinfect the water, but you don't have to have that chlorine in the house once it gets in, once it's done its job. So, you know, that's one of the keys. Before 1900, the leading cause of death in the United States was cholera and typhoid. When was the last time you heard of anybody dying of cholera or typhoid in the US? It just doesn't happen because of chlorination. So chlorination is important to help kill the bacteria, but on well water or city water, if you're using it, use a carbon filter, take it out, and you're good to go.
And the last question that we get as far as the caboose, if you will, in this train is, some people say, okay, I have all of the, you know, I have the sediment filter and this filter, and then maybe a UV light. And do I need a point of use filter too? Because a lot of people say, should I put, for example, a reverse osmosis system on my kitchen sink for the drinking water? Under what circumstances would that also make sense to supplement the items that we had just discussed?
By my way of thinking, and this is, you know, I'm not saying it's entirely right, but I grew up in the water treatment business. My dad was in the water treatment business, and I've probably drank reverse osmosis water for 45 of my 70 years. And, you know, the reason I do is, number one, I don't like drinking softened water. So if you're softening the water, doing that sort of thing, I don't like the taste of soft water. But number two, reverse osmosis takes out the largest spectrum of contaminants of any water treatment process. And since World War II, we've developed over 30,000 new chemicals and compounds. And now we're hearing a lot about PFOA, PFAS. These are forever chemicals that are in the water. Reverse osmosis takes that out, but it takes out a plethora of other things too. So by my way of thinking, if I had chlorinated water, which I do, I'm on city water, I have a carbon filter, takes out the chlorine for the whole house, because the largest organ in your body is your skin. You absorb a lot of chlorine through your skin and through vaporization and inhalation in the shower. So I've eliminated that. I eliminate the possibility of bacteria. And, you know, at that point, I think you've done the most you can. So I'm a big advocate of reverse osmosis. Some people say, well, the minerals, what about the minerals in the water? Doesn't reverse osmosis take out the minerals? Yeah, it does. Are the minerals good for you? Yeah, they probably are. But it's not a significant source. You could drink a bathtub full of water a day and not get enough minerals from the water you drink. So you're getting minerals from food, which, by the way, with the over farming and all this stuff, we're not getting nearly as many minerals in the water as we used to, in the food as we used to. So if you're really concerned about that, then you should take some supplements too.
So just to recap, you go from the well, the pressure tank, sediment filters, and then a specialized filter depending on the test results that you should get, and then to the UV or some sort of bacteria treatment. And then if you want a point of use system like reverse osmosis that we just covered, as kind of a last line of defense. Is there anything else that you would add as we kind of look to put a bow on the whole well water guide here for people?
Well, some people are interested in alkaline water. That's a big thing right now. And we sell a system. It's called the Libation Hydration System, which produces water with a pH of about 10. It's got molecular hydrogen in it. And you know, the jury's still out. A lot of people say it's great. Some people say it's not. I have it in my house. I don't know. I mean, this is an area of, there's 4 major universities doing research in this right now. None of them agree on how it works and what it does and the benefits of it. So it's all the rage right now. Everybody's selling it. We're selling it too. I have it because I'm trying it out, but it seems I've had it for a couple of years. I like the taste of it. I didn't like it at first because you get used to certain things. It's a little more, what's the word? Mineral tasting. But I've gotten used to it. So, you can just use regular filtration, but if you've got a softener, it's not going to take the sodium out. Sodium isn't a big worry in water. Some people say, well, I'm on a no sodium diet. No, you're not. You got to have sodium to live or you're going to die. But in a typical water softener system, you could bottle the water and sell it as very low sodium under the FDA rules with a water softener. So it's insignificant. Mayo Clinic has said the amount of sodium put in the water softener puts in is insignificant. I hate the taste, so that's why I don't drink soft water.
So we covered well water A to Z and then some now if you're into alkaline water. And I will put all of the links and information that we talked about in our discussion in the description. So if you want to check it out, you can go down there and look at some of these options for yourself. And thank you so much, Mark, for joining us. I really appreciate taking the time. You're literally the best possible person I could have think of to be explaining this to all of the people watching that have well water. So I really do appreciate it. And what is the best way for people that want to follow you, what you're up to? I know you have a blog. What's the best way for people to get in touch with you or follow along?
Well, the blog is a good way. I respond. I don't have anybody that does the blog for me. I respond to it. I respond to every comment, or at least the ones that are coherent. Sometimes I have to dump a few, but I respond to the ones that are coherent. And you can go to uswatersystems.com. You can fill out. I'm available. I get a lot of calls. And so I can't necessarily answer them all, but I'm available. And we have a lot of certified water specialists on staff, some soon to be master water specialists, including my son, who's our COO. And so, we're available and glad to talk to anybody to help them with their water.